This isn't 2 decimal points. It's 10. It's 10 wide.
Okay.
As long as you have the decimal point someplace in these 10 places, you can use as much as you want.
Okay.
Maybe just my clarify. The full-on input file, like you said, you have 10 spaces to fill up with. With the 1 point, you only have some variables you
6.
have 3, some variables you have others.
Yeah.
But in the 1 point, you can go into the code and change. It's a formatting statement. It is a
Right.
single formatting statement
We-
that you could then change
we did.
for the 1 point.
Right.
But you don't have those same.
Okay, that's okay, fine. I'm not advocating changing this, but I think what I had in mind was a web interface where it was just like any other form you fill out. It comes up pre-populated, and you can go in and just change
Yep,
that.
and that would be great.
But we need a way to do that. Now I want to run 200 cases or 500. I think that needs.
That's where it
a
gets.
lot of
That's where it
thought.
gets tricky.
That need a lot of thought.
So long, was bringing up this a little bit, that you get some sort of input file generator, that's fine. Then you don't have to worry about changing KRC to deal with it. And then you can plug it into things like DaVinci or IEL or the website. But just a way to generate input files where, oh, I hover over Dell Jewel, and it'll tell you what that actually means. And it's just a link to bits. I mean, or it's
Yep.
literally just a description. You have all of them. They exist. It's documented. It's just
And it's documented with a system that tried to keep it to 80 characters too. It's but it's
You
true.
envision that the thing you just described in what?
It could be several things. It could be something that's a website calls. With DaVinci now, we can actually make web calls, right? So you can say, I want the standard input file that has a change in the first element of the first method, and then it just populates and returns the files. That's pretty straightforward.
The making something that generates this part and the next little part is pretty straightforward. Making something that deals with the change rows or change cards is going to be a little more involved.
Right, but that's where I want to get to, because I
Yeah.
think this tool would have a factor of 10 more use if anyone who was an engineer who wanted to know what the temperature of the MSL landing site is going to be a year and a half from now could go to a site, type in some latitude and LSVS, hit go, and get a temperature back.
You know, Sadat and I have already talked about putting in elevation automatically from longitude.
Right.
And
I mean, those
all
are the
kinds
type
of things, yeah.
tools that would make this.
And so, as currently implemented, KRC has 2 input modes, normal and 1 point. And in fact, if you were super clever, you can change back and forth in a single run, but I don't recommend it. But I mean, the thing is, there's just lots of capability here. And so having a web interface that prompts you, in a sense, color codes the things that you should, that are physical.
We've talked about it, I've talked to you about it, talked to Ken about it. You type in a lat long value, for example, and a minimum set of parameters. You get a form with default values filled in. You type in your lat long, and it pulls up your albedo from, let's say, a test albedo map or something like that, a thermal inertia from a test thermal inertia map. And now you have everything filled in. You can overtype it on it if you want to hit go. It returns you the 2 or 3 values that it returns. There you go. That's a very basic, simple code. Excuse me. The other approaches are you do the same thing, but now you upload a file. You have the 2-column input mode. The rest of the things you want the system to fill by itself from the input mode. You upload the file, it runs it in 1 point mode, returns you the results, hands them back to you to do whatever you want. Third mode is, it is the master file, everything in it. You are responsible for making sure that you have it properly typed and everything. And the fourth mode that you've been alluding to is present this as a matrix in front of the user. And you have all the columns, it's laid out exactly, you can hover over something and it can help about that particular field,
Yeah.
give you more details.
I would, if we're going to do that, which I think we should, I would reorder, the appearance would be reordered.
Okay.
And things would be, they would grouped. I mean, we put some thought into this, but they'd be grouped because the code to map that into this has got to be trivial.
So even given that, there is sufficient number of parameters in there that you can change, modify, override, shoot yourself in the foot with, that I think people need guidance. They cannot just arbitrarily pick up something. We can present a default run, even for one input mode. There are certain defaults in there that can be overridden. It makes sense to override them in certain cases based on the conversation with you. And we haven't talked about that. Hopefully that will come up tomorrow sometime.
And we can,
These are the things.
yeah, we can have, I mean, I can imagine this, you can have different levels of users.
Yes.
You know, novice, expert, and, you know,
The web
that's fine.
interface for the most part is for the novice user to get them going. Once they are kind of into the process, here is what you uploaded, this is what we built for you, here is the input file that we built for you. We can make it a part of the download package that you get once you run KRC. And now you have the input file, the output file, okay, now I understand, this is what I input originally, this is what it produced, and send it to KRC. At that point, people should be able to be comfortable and input a master input file. That's my thought, and you can.
I agree, and I think the key is to get past the theoretical talking phase and into the prototyping and building and testing and improving phase.
Okay.
So the less time we spend
Right. Okay.
talking, I'm hoping at the end of Wednesday that thing exists.
Okay. So the basic implementation of here is a 1-point input file or a master input file is already on the web. Ken did that maybe a couple of days ago. Had a few iterations with you, so it's already up. The things that need to be addressed still are how the distributions are going to be made, how the distribution come over here, how do you validate that. These are procedural issues that need to be figured out. The web development part of it, in my mind, as soon as Joan is free from her current responsibility to MSIP, she's going to take over some of the development that's going on for this particular website. It might require submitting jobs to the cluster, for example, if you submit a very large master input file, for example. So that, in my mind, is going to take longer than day after tomorrow to get that done.
One of the things that you can do, which I've never done but could do, is you can build a CPU predictor that says how long this job's going to run. That would be reasonably accurate, I think, under certain restrictions. If certain parameters are not changed, here's how long it's going to run.
Okay. If you
And
have
all of those
information.
things are, and we've done all those things at least one round. The test vanilla query tool that we already have going
Yes.
does a round of predictions and says, based on your initial inputs to that particular tool, says, okay, this is going to run way too long, cut back on whatever. And then once it does, we put in place how it submits it to the cluster and how you get that data back. And so, and it runs great. So those are some tools we already have in our toolbox that we can mimic, obviously making the changes appropriate for this tool. So let's not forget that we have addressed some of these issues already.
Yeah, and an amateur could generate a lot of output, but it would be pointless because they don't have a clue what to do with it. I mean, this thing is fast enough that the amount of time that you spend computing versus using the output is negligible.
And my sense is, in the modern era, if somebody used one of our CPUs for an hour and wrote a 10 gigabyte file, who cares?
Fine.
Yep.
That's not the issue. The issue is you have infrastructure in the middle. Do you you want to run a 1 hour job or a 5 hour job on your web server, or do you want to submit it to the cluster, have the response come back and send it back to the user?
Okay. Those are all your problems, thank goodness.
Complexities
Right.
that a simple solution doesn't have to deal with. Like Ken implemented a solution running directly on the web server, it doesn't have to deal with it. Once you, excuse me, once you say it's going to run for 20 minutes, we have load balancers in the middle, they are going to say, oh, I haven't seen any activity. I'm going to chop this connection off.
Yeah, no, I understand that.
Okay.
Let's not.
Implementation
Let's-
details.
Let's not get too carried away with trying to make it too sophisticated and worry too much about stuff.
Yes, and that was the point behind having the initial cut to the website.
Okay.
That we're not doing an over-design at this point, because we don't know exactly how to evolve the design.
Okay, this is a different part. It follows immediately the above section. Things get a little different here because here's our latitudes. You can have up to, I think, 10 latitudes in a line. It will read the number of lines it needs based on the previous N4, the number of latitudes. So the number of lines here depends on how many you've defined, and are going to use. So this could be one to 4 lines based on how many latitudes you've asked for. And then for elevations, it needs to be the same number of lines. And that gets you to this point. And then from here to here is arcane mystery. I couldn't tell you what these numbers are without a lot of study. But I know that the ensemble of this block represents all you need to know about the geometry of the Martian orbit, pre-computed in matrices so that what KRC needs to do at a given time step is really small. That's what this represents. It pre-computes into this fundamental way, the best it can, all of the aspects of the orbit and spin axis of the body and distance from the sun and so forth. And that's run offline in a p-orb, which I will talk about briefly. And then it just cut and paste, plunk it in, exactly the way it appears in the other output.
You had some examples for other bodies, but yeah, this has always been it's just, this magic block of numbers.
It's what it is. Yeah.
One thing that I've wanted was some means of understanding how to create my own random block of numbers.
I'll tell you that. In fact, that's part of the system now. Will be part of the web system. And I've written a user's guide to p-orb, which you probably haven't seen, which takes you keystroke by keystroke through how to do it, using the existing thing. We'll get to p-orb in an hour or so.
Or a pre-computed list of blocks.
Well, what I do in the moment is like Tim Titus says he wants to work on, some Titusville asteroid or something. He'll tell me, and I said, okay, you give me the orbit, and I'll generate the block. And because it's cut and paste plug-in, that works fine. And I'll do that for virtually anybody.
There's a tool that did generate the formatting for the input file, right? That's really what we're still talking about. You want to change this number, change that number, change the block of numbers. You just have several pre-computed ones, then you can add your own later if you want to.
Yep, well, we'll see when we get to it. A lot of that stuff is sort of more or less there.
Well,
Okay.
Would it even make sense? I mean, we know of the 40 most commonly studied objects in the solar system. Couldn't you just compute them for those 40?
Well, 10 years from now, it'll be 60.
Okay, but for right now, it's 40.
Which solar system?
This one. But look, I mean, okay, Titan's come up, and the Moon has come up, and Mercury has come up, and RQ-36 has come up, and Mars and Phobos and Deimos, and okay, so I'm running out of things here. Well, okay, fine. But I still think
The
it's 40.
answer is yes, I could, but there's there's two problems. One is it's a pretty long list, and second, I don't want us to be responsible for the values of the orbits and poles, particularly the poles, because they are generally, except for the planets and the satellites, they aren't well known, and it makes a huge difference.
No, I understand, but
Anyway, so I
Could we just write Mars or Moon and somehow something happen, magic happen?
absolutely,
HHK magic happen.
that can be done.
This block of numbers so that without anyone touching, except for writing Mars or Moon. Does that make sense?
And the answer is yes. I think Sadat's taking a note. We need to, you're asking whether or not the input file itself changes structure.
Not the input file, but whatever we want to build just above that.
Oh, you mean above it? Absolutely.
I type in RQ36 and a miracle occurs.
Right.
And I,
That's right.
I guess
And the,
what
mi-
I'm
It
saying,
comes on and off the right, so like the atmosphere comes up by itself.
Yeah.
And then,
well,
yeah, you can do that.
Yeah, and that's the web page or whatever, but just this block of numbers, there's a pre-computed set of them, but RQ36, for example, the rotation rate and other aspects of it are going to be far better known in a few years, and so somebody's going to have to change it.
well, let me ask a question, and I think we're getting ahead of ourselves, but when I asked you for RQ36, you said, go get me, and I went to a NASA website, and I pulled down the best known values. Aren't the best known values of astronomical things stored in a standard format in a standard place?
Partially,
So
yes.
The website does that, gets the thing, runs KFC's P-orb, and populates the numbers.
It can do that. All that's practical. Yep.
And that's,
I mean, again, we're talking. There's two classes of solutions where the input stays the same, and this is a preprocessor at some point. That's perfectly straightforward. In some senses, when you get into the gory details, you realize some of the things aren't that well known, and there are different people's opinions. Are you going to use Sturms or Seidelman, two different experts who have different values? And of course, the difference between them is completely trivial compared to KRC, but nonetheless, they're different. So, at the moment, today's discussion is what do we have now, and then we can raise these leans against it. And this is clearly a lean against this thing, the fact that this is 60 words of magic. But it's blazing fast magic. How's that? Okay. And then at that point, this is as far as that's the block input. Everything after that are what I call change cards or change rows or whatever you want to call them. And KRC is going to keep reading until it gets to a leading 0. And when it gets to a leading 0, it's going to say that's the end of the case. That defines a case. I'm going to go off and run. And it goes off and runs. And then it comes back to that very same place and looks again. Ooh, look, here's some more things to do until I get to another leading 0. And that defines another case. And it goes off. And it'll keep doing this forever. And literally forever. But there's two codicils. One is if you're outputting a file type, if you're outputting files, at some point it won't have room to store the answer anymore. And it'll continue to run, it just won't store the answer. And that's a lean against KRC. Maybe it's probably not a very important lean, but that's what it actually does. It just continues to run, and it does not output to the file.
Is that only for the bin files?
Yes, that's for the bin files.
Because if you do like the -1 for P4 out,
It'll just keep going. Yep. Okay. However, you should be careful there. You should be generating a new case for you should be generating a new file for every case when you're using the sequential access files. Side issue we don't need to get into just now. But this goes on until it finds 2 zeros in a row. When KRC runs into 2 zeros in a row, it says exit. And it's done. And that's the essence of these input files. And it's not uncommon for me to generate 50, 90 cases at once. where I'm only changing a few things in a very consistent way, so I end up with a consistent set of cases. And that's the way the production mode things are run. And so we're not going to get into the guts of this here. I'll tell you a little bit of how it's generated, but it doesn't really matter. So the change cards have a structure to them. They have two integers, a real value, and a text field. The first one tells you what kind of thing is it. 1 is a floating point number, 2 is an integer, 3 is a logical value, and then other things mean different things. 8 turns out to be a disk file name. 12 turns out to be new specific heats. 13 turns out to be new conductivities, temperature dependent conductivity. So there's a series of things you can put in here, including names of climate models, names of seasonal albedo files. There's lots of things, and it's structured. But that first character, and this is described in help list page something or other, is what kind of thing it is. The second integer is which of that set is it. And this is a one-based count through the floating point or integer fields. And then the third one is the value. For instance, 1 is floating point, 12 is global pressure, and this is the actual value in pascals. And then comes a text field surrounded by quotes, which is only used as a print field. It just goes to the output and isn't stored in any other way than that. And then Fortran allows you to have a slash. A free slash tells the input processor to stop reading and leave any other fields that you may have requested unaltered. It's a peculiarity of Fortran. It's a wonderful or not as you like it characteristic. But that's an aspect of Fortran. A slash, and this is what's called list-directed I/O. A slash terminates the processing of the list of things you've asked for and leaves the rest unaltered. Now there's another. I have the habit of putting in this text field if it's a replacement value like this. This is the 12th. There's the 35th of the floating point numbers. I have a habit of typing in there what I think I'm changing. And the reason for this is, one is this horrible old structured way of doing things. You know, what if I thought I was changing this, but actually I'd put a 32 here and I changed something else? When you look at the print file, it will give you line by line what you actually changed and what you said you changed. And if those differ, you should be aware that something's gone wrong. It's just a stupid, simple error alert system that's built into KRC. And it'll go completely away with any kind of modern interface. The next one is interesting. This is something which I say, if we can do this with a web interface, it'll be wonderful. Here's what we're going to do. Look in detail at the temperatures for the first 30 sols of ice freshly exposed at the bottom of a conical pit. Does it at 3 latitudes, 5 cases. 1, the ice is freshly exposed to a full hemisphere of sky, followed by pits with slopes of 45 and 25 degrees, and then these same 2 pits with a different initial ice temperatures. You can do all that in a single KRC run. And I guess Josh is probably the only one who's seen this level of complexity here. But this is the kind of stuff it's capable of. And here's the set of cards. There will be a test on this later. This is the set of cards that does that. It actually, remember that everything until the first 0 is the first case. So here's the first 0. So all the stuff up here is setting up the Phoenix potential landing site, basically. And it's going to run that case. See, I put in new latitudes, I put in new elevations. I've changed all kinds of stuff, number layers, starting times, everything. Then I get down to here, and finally, I put in an azimuth, and it's a number bigger than 360, which doesn't make any sense. And that's a flag that tells it, oh, this isn't the direction of a slope, this is a pit. It's a conical depression. And here's the slope of the wall, and it runs. And now here's a different slope. And now I'm going back and resetting the slope to the value I had up here and changing the initial temperature that we're starting at. And then I'm running that second slope again. So up to here, I'm setting up North Pole of Mars, ice, all kinds of stuff. And then I'm running these 4 additional cases.
So just to be clear, you make a bunch of changes, all subsequent cases assume those set of changes.
That's right.
If you want to change them back to the defaults,
You have to, right. It's, KRC input is incremental alteration. That's all you need to, those are the 2 words you need to remember. I just dreamed them up. In incremental alteration, it just changes it changes every time it comes to a card, it changes that value in the big common field where all this stuff is stored. Now, the other thing is I could have done all of this by changing values in that block of input statements. It would be really hard to figure out what I did. It's my personal habit. I like to start with the default for Mars, and then I list on change cards all the changes, because it's a record of what I've changed. These are all, yeah, until the first 0. That's where the first run starts.
So you can almost have this sort of default top piece or default set of things. You can change your own stuff. So you
Right. You could always have one master file, except you may. The thing you mentioned, it makes sense. It makes sense to change some things in sets. One of the first things it produces out to the print file is a table, what's called a table file. And this lists for each layer the thickness in scale in diurnal skin depths and in meters, the thickness of the layer. This first one is virtual. Remember, the surface is right here between layer 1 and 2. The center depth in meters, negative, it's up in the air in scale and meters. The mass, the columnar mass above the bottom of this layer. How many, kilograms per meter squared do we have resting above the bottom of the layer?
Just the solid, not counting the atmosphere.
That's right. This is above, yeah, there's no atmospheric pressure. And so it's, it's 0 at the bottom of the atmosphere, and then it's 11 kilograms per meter squared at the bottom of the first layer. And this is the safety factor in convergence. And you see how it's got jumps in it. It jumps up and down, up and down, up and down, up and down. Down here is the bottom layer for each time doubling. This one, it's so conservative it starts doubling at layer 2, which is barely into the surface. 2, 4, 6, 8, 10, 12, 14, 25. This is the 7th one because I only allow 6 doublings. Here's 1, 2, 3, 4, 5, 6, and then it's maybe 7. I don't know. Anyway, the bottom layer is 25. Here it is. Now, the important thing here, in some senses, is this column, the scale depth, the diurnal skin depths. The time constant for a thermal diffusion model goes as this linear scale squared. That's just the dimensionality of the problem. A year is 680 days. The square root of 680 is roughly 26 or something. So if you want to run at a year, this is roughly the depth of the annual thermal wave down around layer 19. And I'm running 3 times that in thickness, which is roughly 9. So I've got a system that's got a total time constant of about 9 Mars years, roughly, in this particular case. The other thing that's printed out up here are the actual values for conductivity, density times specific heat, diffusivity, and the scale factor. This is a convergence between meters and diurnal skin depths. If you've turned on the temperature dependent flag, a new table appears. This one I don't think many of you will have seen. This is the additional material that comes out. Here's some things I've changed. This is the third item, which means it's logical, the 10th location, and the value of 1. I turned on LKFT, so this is the thing I typed in that text field, and this is what the program thinks it is. That's why the K's are different. I just was sloppy. But this is my alert that, okay, I think I changed that. That's what I actually changed. And then there are a bunch of parameters. This is actually 8 parameters. That's why it takes so long. These are the coefficients for conductivity for the upper and the lower layers. These are the 8 items that were in the input field as read by the program. And here are the 8 items for specific heat. The first 4 are for the top layer, the next 4 are for the bottom layer. And then there's a table of the value of conductivity and specific heat and thermal inertia of the upper layer, and the same for the lower layer as a function of temperature from 130 to 320 Kelvin. So you can see what's actually going on. In this case, interestingly enough, the thermal inertia of the upper layer increases with temperature up to a point and then decreases. And that's because we got this counteracting cubic effect between conductivity and specific heat. That's for this particular case. It may or may not do that for other materials, depending on what you use. And then here's the lower layer. This is ice. The thermal inertia is decreasing as you go to higher temperatures. And then it produces this little thing here, and this is a critical little thing you need to really look at. This is the input values that you used for the temperature independent values, the ones that are stuck in that upper input in various places in the input file. And this is the temperature dependent value at 220 Kelvin, which should be the same if you're going to switch between temperature dependent and temperature independent cases. You should be assuming roughly the same thing for the upper conductivity and the lower conductivity, specific heat, and so forth. And lo and behold, oops, I messed up I did something wrong. If I compared these two cases, they should be dramatically different, because what I assumed for the temperature independent case and the temperature dependent case turn out to be very different. This is an alert. It doesn't actually check anything. It just prints this out and trusts that you'll look at it.
So you're saying that 3.4 and the 2.7 should have been closer together?
Yep. If you're going to compare. So what it basically, I put this in just as a check because it's so easy to make mistakes, particularly with this scaled stuff and, cubic polynomials. I found this to be a handy table, and this is something you really want to check.
This is also the type of thing where it seems like whatever front end we have for this will have standard cases, right?
Yep. And it can certainly check, and it can warn you. If you turn the LKFT flag on, it can alert you that, oh, the values that would have used if this flag was turned off are different. You may or may not care, because it could be you just ignored that part of the stuff. Okay, now we'll go to some of the simpler stuff. This is the 1-point mode, and there's 2 slides that are almost the same on this. But you have to understand how the 1-point mode works. The 1-point mode actually works by first, it starts up the normal mode with the same input file, the same set of change cards, everything down to the first 0. And normally what it does is it reads a master file, a normal file, which is set up to calculate the 1-point mode. So it's only going to do 1 latitude. It's only going to do a moderate number of layers. It's only going to run for a moderate number of days. It doesn't do annual spin up. It just says, okay, I'm only interested in 1 point. I don't care about the prior 2 weeks of time. I'm just going to I'm going to forecast everything for this location, the Mars orbit. That's it. I'm not going to worry about last year or the polar caps or anything. And so it reads that file, and that sets up KRC with whatever parameters you like. It's the exact same format file. And then it reads one line, I think the leading character is 11, that says, oops, this is a flag, go to 1 point mode. And here's the name of the file you want to read. And it goes off and reads a file, line at a time. It reads one line, runs a case, reads another line, runs a case, and so forth. And this is what's in that line. The season, the latitude, the time of day, the elevation, the albedo, thermal inertia, dust opacity, slope, and azimuth. Those are the complete list, and you have to specify all those in a highly structured input file at the moment. And it will run a case, and for each one, it will generate 2 terms: surface kinetic temperature and bolometric top of the atmosphere temperature.
Why do you not want to prime the system beforehand, like the 30 or 40 days that you run?
Because L sub S can be different for each input. I mean, you could go back to KRC and set it up that it's going to run a large number of seasons and then run in 1 point mode. You could, instead of running 15 days, you could run 15 plus 689 days if you wanted, or several years, as long as you get to the right stopping time. But the 1 point mode, the current, and that's, I guess that's a characteristic. The 1 point mode can be whatever you want it to be, because the user could change the input file, which is what defines a KRC case. And all the 1 point mode is, it runs a normal KRC and then it extracts the value. The only thing really in here that's strange is the hour of day. Everything else is a normal KRC, either input or output. But it goes in and picks the time of day you asked for, and that's the one it puts out. It doesn't use the hour system.
So, for those who are confused, I mean, give us an example. This was written for speed and simplicity.
Mm-hmm. At request, somebody asked for it. You said do it, then I did it.
Okay, I'm trying to think of, if I'm sitting in the back of the room thinking I'm confused, when would I run 1 point? Because it sounds like
it was written for Themis when people, I don't recall, I don't know what the personal motivations were to do this. It looked like a good idea. It's easy to do. Some people wonder, what's the temperature at this time of day here? I just,
Right.
It's very, very convenient for quick and dirty back of the envelope kind of calculations.
Right, but
See,
I guess my point is, so I used it for that 1.5 billion cases where I wanted to make a movie throughout, but I didn't really care what the exact temperature was. I didn't care if it was off by 5 degrees.
We wanted consistency.
I wanted consistency, and I wanted something I could compute in a weekend on the cluster. But these temperatures, because they're not doing the full 3-year spin-up, converge, etc., they could easily be different by 5 degrees.
Figure something or other in the paper. It's actually in the paper.
But if you want to do it carefully, you can't make it run for 5 years. And in reality, the differences that you get from the 1 point and the differences you get from the 4 are often not that. In my experience, it's been tens of kelvins, not
If you stay away from the polar regions, particularly, it's going to be small.
no, like tenths of kelvins, like point 1, point 2, half a degree at the most.
I didn't even bring a copy of the paper with me, but if anybody has it, there is such a figure. It's like figure 3 or something.
Well, I'm just saying, my goal, and it's maybe different from yours, is to eliminate as much confusion and have, just, it's fast enough now and simple enough.
Where are my glasses?
Interface that ran the full model.
Oh my goodness.
Technology.
As opposed
Something in
to,
there.
Oh, it's going to be down in the figures.
You could run this, you could run that, you could run this, you could run that.
It's got to be this. Keep going. It's past all the references. Whoa!
Kind of a front end for the full
There it is, figure 4. And
No longer need.
why doesn't it have?
But if I understood what.
This is interesting, it has no label.
Label. Doesn't do a 3D.
I must have read, it got cut off. This is Kelvin, I think.
But if you're going to change it to run a full up.
It's just missing the labels in the y-axis.
Yeah, there wouldn't be any need.
Okay, it's figure, here's figure, it's figure 4. However, this particular version doesn't show the y-axis labels, which is, I hope the major paper isn't like that.
Here, hold on. I got this. I think this one does. I mean, if you're looking for differences, for example,
It just turned around on me. Does
what's
it do
the
that?
what is the difference in, at LCMS 90 versus 110 for a thermal
Okay.
ownership X?
There are the numbers. This is integers in Kelvin. Most cases are.
It's a few Kelvin. It's plus or minus 1 Kelvin.
We,
The main reason why I use the 1 point over full if I'm choosing to do that, so I don't have to deal with the full output. If I want a really simplistic output and I don't want to have to calculate in local time,
Right.
because it only outputs every hour, it doesn't output any hour.
Right. But I would argue
Or
that
anything.
rather than having a different mode, I would say you'd have a different output style.
If you want something quick and dirty, 1 point.
it's,
I guess what I'm trying to say is, as we try to maintain something here, the 1 point might go away. We might just have a better GUI interface and a cleaner GUI output. And
Well, yeah, clean and DaVinci interface too, but yeah.
That's one thing that I'll harp on a little bit. Like, if we do this, I would like to, I don't really want to volunteer for anything, but I will.
I nominate Chris to do
I
all
second
the
it.
work.
With the DaVinci interface, I mean, if we can work with somebody, maybe whoever is doing the website stuff for the generation of these input files, and then running KRC, there's no reason why DaVinci actually can't point to the website if it's done in a proper way, if it's done via like an app server. We already do this all over DaVinci. And it works really, really well. We do it for database interfaces so that the end user doesn't actually have to download KRC and worry about compiling it. So they use the version that's the last KRC and the repository. And I think you can do lots of these things, and then you can make it very flexible. The website
Well,
uses the same thing.
you should look at the website, because at the moment, the 1 point interface is really simple.
Right. It's not flexible at all right now. And I think if you spend a subgroup and spend a little bit of time discussing
Well, no, I'm sorry, it's very flexible. If, yeah. I guess actually I don't recall how much, I don't know if the current website probably doesn't allow you to change the master 1 point file. But that's all that's involved here.
Yeah, I agree. I think the interface is actually, it's just providing some sort of standard cases, standard uses, and standard outputs that people actually want on a regular basis that won't allow them to change.
okay, I'm going to propose that I quit interrupting and we let you just get through today's material, because I really do think a lot of this will just benefit from just doing it.
I agree.
As opposed to,
And I think like you said earlier, it's not, you don't have to lose so much.
Oh, that's handy. My goodness.
So we'll see if it comes up.
Well, I'm going to go on to the next one. And this is a typical 1 point, this is just a 1 point file. And actually this is, at the moment, this is sort of provided for you. There's a top line, which is just instructions. And here's the next line, and you actually align everything, which isn't aligned in this because it's not Courier. Sorry. Or is it? It's not actually aligned right. But basically, you input these items aligned so that the right-hand character is under the right-hand character of the word, and it clearly isn't in this PowerPoint thing. It actually reads a master file, runs everything, and then adds 2 more fields out here, and that comes out in the output. So beneath the 1 point is the full KRC model. That's the thing that's important. It's running the full model for every point, one at a time. And we've already talked about this. I mean, if people had access to it, they can copy and modify this. So in fact, you run 1.25 years for every point. And now production mode. And I've forgotten why I put all these colors in. I've edited this a little bit. Production mode is really the 1 point mode with this ordered set of changes. And whatever set you want to run. In fact, the set that was used for tests, there's a grid of albedo, opacity, thermal inertia, surface elevation, latitude, and then hour and season come out of the way things are run. So you end up with lots and lots of files, most of which normally are the sequential access files. So there's one record per season. And the interpolation scheme is well, we don't even need to go in. This is outside of normal KRC. And the important thing here is that generation time is not an issue. You can do all of the Themis model sets in an hour. And as I said, Mellon models take a CPU week to run. And this is the set that was run for Themis. 48 times a day, 37 latitudes, 168 spin-up, and then 84 actual seasons, 3 albedos, 3 opacities, 3 elevations, and 10 inertias. So that's the file set. So it's basically a pretty elaborate, fairly full output for 90 cases. And nowadays, that would run in, 20 minutes or something. So here's what you get. The print file lists all of the changes, then the resulting full input list after you've made the changes, then a layer table, which should usually be contemplated. I mean, look at the layer table, make sure you're doing what you want. And then, I didn't put here, then there is a temperature-dependent properties table if you asked for that. You can turn on all kinds of output, and I'm saying here, beware, it can get enormous if you're not careful. This actually should be an 8. It's got 8 kinds of binary files, and they fall in 2 classes. The Fortran direct access, there's 3 classes. This is the one that's normally used, -1, and it outputs the common, which contains all the input parameters, then surface kinetic and volumetric temperature for each season. There's another one which is, I don't know if anybody's using, which outputs things versus latitude and depth for usually very restricted seasons. Another version which is used basically to check out things. It only does 1 latitude for each season, but it gives all kinds of details about the temperatures of the subsurface. And again, these are they're left over sometime, someplace in the last umpteen decades. They turned out to be useful. The bin5 binary files. Now, bin5 is a type of file that has nothing to do with KRC. It's just something I developed because I was trying to interface files with colleagues and keep things for myself. bin5 is a file that can contain a text section, normally short, and a binary section. The binary section is a single array of any type and virtually any number of dimensions, but it's a single array. And it is described in the text section. The text section tells you how many dimensions and what the size of every dimension is and what type of file it is and when it was written and what was the word structure of the computer that wrote it. So it knows about byte swapping and will do it automatically between if Josh and I are on different styles of computer and exchanging files, bin5 takes care of it. The reader and the writers automatically swap bytes as needed. But it only contains one binary array. Anyway, and it's used for all of the bin5 types, of which there are 5 or 6. I don't remember anymore. And this is this is the one we're going to talk about, this particular one, 52, which is actually not 24 hours, any number of hours. And then there are 6 items. I think this is a restriction anymore. Some number of latitudes and up to 80 seasons and up to 5 cases. Now, the complication here comes, and I've not documented this in a file, in this slide set. KRC has a subroutine called tdisk that does all the disk interface. And when you tell it you want to write a type 52 file, it goes in and looks at how big does it have to be for a season and how big for a case. It computes, and what am I going to need? Because I got so many latitudes, so many depths, so many seasons. How much room do I need to store a case? And then it'll look in the common and see how big is the common, the firm coded value for this huge area that I'm going to allocate for this array. How many cases can I hold? And it will print those 2 numbers out. How big is a case? And how many cases can I hold in that array? And it remembers those numbers. And as you run cases, it starts storing them in this packed binary file. And when you get to cases beyond the number it can hold, it simply stops writing them. Keeps running them, but just doesn't write them.
You say it stops writing them to the common area?
It stops filling common. It stops writing them to the common area because the way KRC runs is when you give it a file name, it starts up the file system. If you're doing bin 52s, it keeps that same file, which is a mapped common, running until you tell it to stop. So it's actually, the program is, tdisk is not writing to a file in this sense. It's writing to a structured memory. And then when it's all done, it will grab that and send the part that you used to the actual bin5 routine itself.
So both. So it will stop writing to both.
In your help list, it says that bin52 has 7.
Uh-oh. I need to check that. The help list must be right, so I'll just... So that's the help list. I'll check that. What
What are those cases? 5 cases, 10 cases?
A case, remember in the input file, it reads all the changes you want to make until it comes to a 0? That defines a case. A case is a set of latitudes and seasons for a unchanging set of input parameters. Okay, and I don't know when I generated the slide anymore, but it's sort of dynamic. KRC will adjust how many cases it can hold depending on how large you've defined them to be. This is a somewhat old slide. Yes, it is an old slide. This is all about model sets. There's nothing here that we don't need to know. Here's one, this is one I ran recently, just as an example. 84 seasons, 37 latitudes, 15 inertias, 3 albedos and pressures. and the climate dust and isopacity. So the zonal dust and isopacities were changing through the year as a function of latitude. And I ran it for 15 inertias. This is numbers wrong. It ran from 25. It's nearly, I think it ran from like 11 to 2,500. It covered virtually everything we know on Mars. And there's nothing else here that's important, because that has to do with interpolation.
What's a safe output format if people want to run more than 5 cases? It's not bin 5 because it does not support.
Oh yes, it could be bin 5. The thing is, imagine you're running down this set of change cards,
Yes.
and
So put a new file.
you put a new file name in, and it will automatically close the old one and open a new one. Yes, Bill.
Would this be a time to go to a different, simpler output file, output methodology? Is that necessary?
It might be useful.
You can imagine where every case it just writes to the file, it just writes to a file, it just writes to a file. There's no intermediate common, there's no, it could be 27 cases or 250 cases. Again,
yes, you
I
could
have
do-
the
you could do that.
sense that for many of us, the input and the output for KRC is confusing. I'm
Yahoo.
just trying to think of, would it make sense to just say, let's do a new approach?
I would say you can certainly consider that. I believe the structure of the program is such that it could be cleanly accommodated, because all of the disk output is in one routine, and it's pretty highly structured programming between, there's the sequential access section, and there's the bin 5 section, and we could add another section in there. It's a pretty clean interface. What you would want to consider is does it need to be a self-describing file or not? The thing about bin 5 files is it's pretty bomb-proof in terms of transferring between people, because everything about the binary aspect of the file is guaranteed to be in the header. Whether or not there's enough scientific definition is up to the person who wrote the file. But you can put, lots of text in there if you wish. So the answer is certainly one could do that. The second difficulty is anticipating what the user wants to have in that file. But absolutely.
I'm not saying it's the right answer. I'm just saying, I don't know what I'm saying. Even just going to ASCII files or something, or common.
Oh boy, I wouldn't do that. You could.
Phil, we've kind of discussed that on the input side, that an interface to protect the user while still maintaining the KRC native input file, for lack of a better term, might be the way we kind of are heading. And I'm wondering if maybe the output might be the same way, that on the website we take the native KRC output, be it 62 or whatever,